We're going on now to the last section of Chapter 6, which is Section 8, dealing with formulas, applications, and variations. Now, one of the things I'm going to strongly suggest is when we go into direct variations here, you think of the formula y equals kx. This is the general formula, and you should take notes on this, of direct variation. And some of you might say that looks a little familiar to something we did in the past, and that was y equals mx, where back in chapter 1 and 2 a little bit, we talked about the numerical coefficient of x in a linear equation in two variables. This was called the Slope-Intercept Equation, where we often had a letter out here, b, which was the y-intercept. But if you just take this part of it, it looks very familiar to this, because that is a direct variation, this part of the formula. So I would strongly suggest anytime you hear that it's a direct variation, in a corner somewhere you write this formula. This is your link to getting the correct answer. And inverse variation, while we're here, is a similar formula. Y equals, now k is always in the numerator, but now the x value goes down to the denominator. So y equals k over x is the inverse variation formula. And then joint formulas is we add extra letters here, extra letters there, and the problem itself will always tell you, is it a direct variation? Is it an inverse variation? Or is it a joint or a combined variation? And then we'll look at models as well. So a little background. Hopefully you have this now in your notes. Now, the first thing they want us to do is something from a long time ago also, is to take this formula, 2x minus 4y equals 7, and we want to solve it for the letter y. All right, you want a positive y, so there's different ways to do it. I would take the positive, well, I would take the negative 4y, bring it to this side, and I get a positive 4y, just by transposition. Then I have 2x, transpose the 7 to this side, it becomes a negative 7. And now I just divide everything by 4. Now you could do it individually, or you could do it all over 4. I like the individual way. So now I'm going to put my y over here. That's my positive y. And then I get 2 over 4 is 1/2 x minus 7/4. I have solved this equation for the letter y. And techniques that we use since the beginning of the course. Now this one I'm going to write big here for you so you can see it. It's d equals the initial velocity of something times the time plus 1/2 a t squared. So there's our little formula. We want to solve it for, and I will change this to the letters we want to solve for. So we want this all by itself, and we want it positive. So we're going to isolate this eventually, but first I think what we want to do is get rid of that fraction 2. And what did we say just earlier in this section, in these sections, to get rid of a fraction? Well, you multiply everything, every term, by 2. And when you multiply this term by 2, the 2's cancel out. Okay. So in fact, I will just get rid of them here because that helps us save a little room. Now, again, we want to isolate this. So we're going to get our next row, our 2D. Now, in isolating this, I want to get this over to the other side. So again, I just transpose it. Negative a t squared equals 2 VO, initial velocity, times time. And you might say, okay, we want to isolate that. So we're going to divide by the 2 here, because these are all factors. And we're going to divide by the t. Well, if we do it to that side, we must do it to this side as well. So now the 2's cancel out, the t's cancel out, and we have initial velocity equals this. So even though it looked a little daunting in the beginning, again, just getting rid of fractions, transposing this to the other side, and then dividing out those items, those factors you don't want, so you get the initial velocity by itself. Okay. Now, some of these are word problems, so we have to read them. And here they're telling us for number 2 that they are direct variation. So what should you put somewhere if they're direct variation? Well, the direct variation formula, y equals kx. So that's your basic formula. Now let's look at what they say. The distance traveled at a given speed d, so we're going to change the letter y to a d now. Now we always have to put the k. That's our constant of variation. Varies directly as to time. So we have converted our basic formula using the letters they're giving us. It says Joseph can travel 20 miles. We put the 20 for distance. In point, we need to put the k in because we want to determine what is our k, our constant of variation. And our time is 0.5 hours. So we want to solve for k. We're going to do that by dividing both sides by 0.5. So we get k is 40. Now what we want to do is to write our equation of variation. Well, it's going to be d equals 40, replacing our k with 40t. because now they're asking how far will he travel at the same speed in 2.5 hours. So we substitute d equals 40 times 2.5, and we get d, and we multiply that, and twice 40 is 80, and half of 40 is 20. That will give us 100 miles. And keep in mind the answers are below. And this is the work neatly laid out in terms of solving a particular problem here. All right, let's look at number 2 now. Number 2 states, find the variation constant and the equation of variation if y varies directly as x. So again, we're going to write this. Y equals kx. This is direct variation. And they're saying y is 15, so we substitute 15 here. We don't know k, that's what we're trying to solve, when x is 3. So we solve this by dividing both sides by 3, and we get k equals 5. Now, 5 is our constant of variation. What is the equation for this direct variation? Well, it will be y equals 5x. Once we solve for k, we put our value for k into our general equation, and that's the answer. So nothing too difficult. Again, we're showing you the strategy to get answers, and hopefully you're picking up on a pattern. All right, number 3, solve each inverse variation problem. Now I'm going to put that right here. What did we say when we said inverse variation? Y equals k over x. And let's read it. Energy of photon of light varies inversely as its wavelength. All right, so what we're going to do is say energy for y inversely k over its wavelength. So we're taking our basic formula and substituting the letters that would be meaningful to what they're asking. If a photon traveling with this wavelength, so we have 200 right there. No, 200 is underneath. We have a k there. Has this amount of energy, 6.2. Now, for something like this, remember we have a technique in which we can cross multiply. So actually, what does k equal? Well, k equals EW. That is, there's a 1 over here. We're just going to cross multiply. K equals EW, which is the product of that. And for there, we get 1240 is what K is. So our formula of inverse variation here will be E equals our new value for K, 1240, divided by the wavelength. And they give us now a new wavelength of 120. So what will E be then? Well, you're just going to divide this into that, and it actually goes 10.3 with a repeating bar. Well, the repeating bar of 3.3 is actually 1/3. So the way they list it in the textbook or in this answer key is that. That is your energy when your wavelength is this. So once again, inverse variation, you set it up like this. You then substitute the letters they're giving you. You want to solve for what K is. We're using just this cross multiplication technique, or keeping in mind K is always the product of E and W, or X and Y. We found out what K was. We got a new W value that we place underneath. Do this division, get the answer, and that's what our energy is for this. Okay, now for this next one, it's also Y equals K over X because it's inverse variation. Now here they're saying the gravitational force between two objects varies inversely. See, they're letting you know this. As the square of the distance between them. Okay, so let's make it a gravitational equation. So gravitational force is equal, inversely, we put our K up there, to the square of the distance. This will be distance squared. So this is what they're telling us. We're just converting this into our inverse variation formula using the letters to help us move through it. So if the force between two objects is 300, so we put the 300 right there. We don't know what K is. And it's 3 meters, so we put the 3 there, but we have to square the 3. So this is actually going to be 9. Take a moment and see if you can tell me what K is. Remember, we're squaring this and getting 9. And we're just multiplying these two. And if you said or thought 2700, that is correct. So we now have G equals, we put our 2700 to replace our K, and now we're going to say it's 30 meters apart. So 30 meters, our new distance that we're going to square. Now, all you have to do is multiply 30 times 30, which is 900, and now divide 900 into this and see what you get. And you should get a 3. And that is the answer. And you probably should put the letter N, which is that symbol for energy that they're referring to. That's kind of a physics thing here. Okay. All right, so again, direct variation, y equals kx. Inverse variation, y equals k over x. And we gave you some examples. And you do have to read them carefully to get an answer. Okay, let's move it up because we're going to do some joint ones now. And we have some room down here that we can work. Well, more. Oh, we can see the answers too. That's even better. Okay, so for 4A, we're going to do some combined variation problems. So it says here, if Z varies jointly as X and the square root of Y, and these are then find the value. So this is a direct variation. Let's set it up using the letters. So it's saying that Z varies. Now we always have to put the K. The K is always in our numerator. Varies jointly as X and the square root of Y. That's our basic formula. So we start to substitute. I'll do it down here. Z is going to be 20. We don't know K. That's what we want to find out. And X is 5. And Y is, remember it's the square root of Y, which is 4. So with this, can we find out what K is? Well, what is the square root of 4? 2. So this becomes 20 equals K 10. Keeping these together, we're going to divide both sides by 10. We get K equals 2. So our formula of joint variation here is, let me put it up here, Z, I'm going to just change this K to 2. Let me erase it, because I have found out what K is. K is 2. So now I substitute. I want to say X is 16 and Y is 9. Okay, so what is the square root of 9? The square root of 9 is 3. So we're going to get 2 times 3 is 6. 6 times 16. And you can use your calculator for this, is 96. So you could have gone 2 times 16 is 32. 32 times 3. Or you could have done it the way I did it. Makes no difference. Hopefully you're going to use your calculator to be accurate. You don't want to do all of this and not get the correct answer. Okay, let's see what B says. If W, let's put it right there, W varies directly. Now what do I have to put right here? What letter? K. Varies directly as the square of Z and inversely, so that means it goes on the bottom, of X and Y. So there's our basic combined variation problem. It's direct variation and inverse variation combined. Remember, K always goes in the numerator. And you just follow what they say. So now we substitute. Well, our W is 16. Let's put it down here. Equals K. What's our Z going to be? A Z is 4 that we're going to square. And then our x and y are a 1 and a 2. So we start to work this out. Well, I'll work down this way here. 16 equals k. 4 squared is 16. This is going to be a 2. What is 2 into 16? That's 8. So we have 16 equals k 8. We divide both sides by 8. K will be 2. So I now go back to my original formula and erase the k because I now have its value. K is going to be 2. So now I substitute our new values here. And we have W equals 2. Now our Z is 5. So we're going to put 5 squared there, which is 25. I'm just saving a little room. Z is 5. We had to square the 5, got the 25. And then this is 5 times 2, which is 10. So this is 2 times 25 is 50, divided by 10 is what? 5. So our W is 5. And that's what we have for 4B. Let's check it out here. 4B, W equals 5. Perfect. Now, the tedious part of this is just, reading it carefully, substituting correctly, and knowing, our background. If it's direct variation, y equals kx. Inverse variation, y equals k over x. You will always be putting k in the numerator. Now, normally when you read the formula, it doesn't say anything about k. You have to know that if you're dealing with direct variation, you must put k in. Okay. Now for number 5. Use the following table to determine whether the data indicates direct variation or inverse variation. So notice what we have. As as x increases, y decreases. Okay. So it's definitely not a direct variation, because if it's direct, as x would increase, z would increase. Okay. So what is it? Well, how about if we multiply these? Ooh, I think I see a pattern. This is 36, this is 36, this is 36, this is 36, and this is 36. So we have y equals k over x, because what does k always equal? The product of x, y. Remember, if we cross multiply, and that's what we see here. So this is this is inverse variation. So what is our formula going to be? Well, it's going to be y equals, now what did we say k was? Well, it's 36 divided by 8. So our y now will be 8 divided into 36, and if you do it carefully, it's 4.5. And that is your answer right down there. How did we get it? Well, we studied the data, figured out it wasn't direct variation, it was inverse. We put our formula, keeping in mind what is K. It's the product of these two. There's K, and then our new value for our Z term down here. And I think they are showing us here, X now will be 8 in our formula. Dividing 8 into 36 gives you a fraction. You could also say 4 1/2 too, but they're using 4.5. Okay, we will be starting chapter 7 shortly, and I know you've had either a test or going to have one soon.